First International Conference on Sustainable Energy and Advanced Materials. OUARGLA, Algeria. Application of a multi-level inverter for optimization of energy for hybrid wind-solar power station system presented by SEAM Gadelberg, Dib, Mohammed Larbi Mihab, Ayman Nimer. In this paper, we're gonna talk about this 5 points below. Point 1, Introduction. Point 2, PV systems. Point 3, Modeling of the 5-level NPC structured inverter. Point 4, DFIG fed by multi-level inverter. And point 5, the conclusion. Abstract. The proposed system consists of solar PV and doubly fed induction generator-based wind turbine. These two energy sources are complementary in nature. The quality of the energy supplied to the network by for hybrid PV wind system using doubly fed induction generator wind turbines could be improved by the use of multi-level inverters. The need of several sources on the DC side of the converter makes multi-level technology attractive for photovoltaic applications, of the same for the wind turbine systems, and by increasing the level of the inverter, we can get an improved system responses by reducing the harmonics of the stator current delivered to the grid and reduces the ripples of the couple. The results under Environment, MATLAB Simulink, will be presented and analyzed. The connection of several PVs to the power grid through multi-level inverters reduces the total harmonic distortion, THD, thus improving the quality of electrical energy. In view of the environmental problems caused by the emission of greenhouse gases, the use of renewable energy resources has become an interesting alternative, offering the possibility of producing clean electricity. The proposed system consists of solar PV and doubly fed induction generator-based wind turbine. These two energy sources are complementary in nature. The quality of the energy supplied to the network by for hybrid PV wind system using DFIG wind turbines could be improved by the use of multi-level inverters. Figure 3 shows the block diagram of the PV system, and Figure 4 shows the electric model of a solar cell, which consists of an ideal current source connected with a series resistor and a shunt resistor in parallel. Diode D describes the semiconductor properties of the cell. This model with an empirical diode is currently the most used because of its simplicity. Photovoltaic generators have a random electrical production directly dependent on weather conditions. Figure 6 shows the flowchart of the P&O algorithm. We have tested the performance of the algorithm by simulation. The results are shown in Figure 7 and 8. It represents respectively the variation of the illumination and the power delivered by the PV system. Maximum power point tracking technique follows the variation of the irradiation with a rather remarkable rapidity. Point number 3. Modeling of the 5-level NPC structured inverter. Each phase of the NPC 3-phase inverter with 5 voltage levels is composed of 8 controlled switches that are unidirectional in voltage and bidirectional in current. These are conventional combinations of a transistor and an anti-parallel diode and 6 holding diodes connected along the DC bus. The inverter is powered by a continuous source E. It has 4 capacitors of equal values to give 4 distinct sources of E divided by 4 voltage. The 3-phase structure of the NPC inverter with 5 voltage levels is shown in Figure 9. With the symmetry of the structure of the 3-phase inverter using the control strategy triangular 4 sinusoidal carrier, the algorithm is defined by the following expressions in Table 1, and Fig. 10 shows the control signals of 3 references and the signals of the 5 bipolar carriers. Figures 11 show the compound voltage between phase A and phase B obtained at the output of the inverter. We note that the results give the following voltage levels below. The Fig 12 illustrates the line diagram of the string conversion wind turbine that we considered in our study. The equations of the stator voltages and rotor are represented below. So, the analysis of these relations and their presentations by the expression 13 and 14 allows presenting the internal structure of the machine in Figure 13. Figure 14 shows the control system. We introduce two control loops, so that each axis control contains two PI controllers, one for controlling the power, and the other for the rotor current. This method takes into account the coupling terms, and to compensate them, it consists to synthesize the control algorithm, from reversing the transfer function of the control system, to develop the rotor reference voltages, according to the active and reactive power at the stator. The DFIG is fed by a three-phase inverter NPC 5-level structure, as shown in Figure 15. Figure 16 and 17 shows respectively active and reactive powers references, as well as the power available to the stator of the machine. It is noticed that the powers follow their references perfectly. The Figure 18 and 19 represent the torque. We clearly see the torque as we increase more the level of the inverter over the oscillation, and delta TE torque decreased, and this is a considerable reduction. From Table 4, we conclude that there are fewer harmonics in the current injected into the network, and less oscillations in the torque when the level inverters is higher. In this work, our attention was focused on modeling, simulating and analyzing optimization of energy for hybrid PV wind turbine system by the use of 5 levels inverters. The connection of several PVs to the power grid through multi-level inverters reduces the total harmonic distortion, THD, thus improving the quality of electrical energy. Their use proves to be an optimal solution for the connection of the photovoltaic system to the electrical networks, and they make it possible to increase the power delivered by the photovoltaic generator. The use of the latter in the areas of photovoltaic high voltage and strong power allows you to solving simultaneously the difficulties relating to congestion and to the command of groupings of inverters at 2 levels generally used in this type of applications. Separate control of powers for the DFIG. Our use was made for power 2 and 5 levels. Performance analysis and power comparison for these levels shows that the DFIG powered by the inverter with 5-level offers more opportunities and improves system responses by reducing the harmonics of the stator current delivered to the grid and reduces the ripples of the couple.